flat earth wars, yes, Oakley screamed and ranted. Aye, aye, the flat earth wars, yes, Oakley screamed and ranted. Oakley screamed and ranted. Oakley screamed and ranted. Oakley screamed and ranted. Well, today is kind of a special occasion for me. I have an opportunity to work with BlueMarbleScience again. He and I just got done doing a big series of interviews that are going to be running for the next maybe 3 months on my channel, where we go over all of the common flat earth arguments. We've got Charlie H., who is an astronomer and spent a year or more working in Antarctica, both at the McMurdo Station and down at the South Pole itself. And BlueMarbleScience is involved in that. And the other little character is a little guy from Australia. You all may have heard of him before. His name is Wolfie6020. And our next episode for that's going to be on Monday. Today we're going to do something kind of special. The other day I kind of beat up on I didn't beat up on BlueMarbleScience. Who would want to do that? I beat the snot out of Quantum Eraser on his little Gravity is Just a Force video, and basically showed that he cherry-picked citations based on a word search that says gravity's not a force, and he didn't bother looking, in many cases, 2 sentences later in the same paragraph, where it says, but for normal circumstances, Newtonian physics is a close enough approximation we can use it without any chance of an error. So I basically humiliated him across the entire internet. Now, he hasn't really formally addressed that yet, but he did put out a quote-unquote toe tagging of me today, which I hope you'll stop by his channel and maybe have a look at that. It's a good laugh. But that was from over a year ago. And he thought by putting it out just before this stream, he could moderate some of the damage. But if you look at the chat on that, it's really funny, because one of the things that he talks about is, like, where the heck is everybody? There's only 12 people here. There's only 30 people here, or 36 people here. We've already got 197 on this stream. Let me give you a little hint, Quantum Eraser. The reason nobody shows up to your streams, is nobody likes you. They're tired of listening to your crap. The only people that come to your streams, Quantum, are the people that are in your little echo chamber. You know, that little thing that you run? That's probably why the streams are a little different. The other day, Big Blue, who is an electrical engineer, all right, not a dumb guy, had a debate with somebody on Jose J.G. Gonzalez's channel, boom, with a guy named Brian's Logic. And to be honest with you, I don't even remember what it was about. I don't think Brian knew what it was about either. I think that was the biggest problem that we ran into. And Blue took a little pity on him and tried to give him that little disappointed father talk, kind of trying to set him straight on a few things. Well, Quantum Eraser took that little performance, which was, 3 hours long, Blue? Or was it 2?
It ran about 2 hours, I think.
Yeah, it was about 2 hours long. And Quantum Eraser cherry-picked parts of it and made a hate video on Blue. And I saw it the other day and just let him know, in no uncertain terms, that if he thought the Gravity video was bad, Blue and I were going to gut him like a deer. And we're here to do that. So, Blue, do you have anything you want to say real quick before we get started with this monstrosity?
Well, I think you summed it up pretty well, Bob. I'm looking forward to this. Quantum Eraser, pay attention.
Well, if you paid attention, you might actually learn something. By the way, we're already up to 223 viewers. Hit some likes and subscribes there, guys. So let's go ahead without further ado and get on over here and have a look at this yo-yo. Now, I cut out the first 5 minutes of the mutual, well, I have a word that I would like to say what they were mutually doing. but this is a family channel. So we're going to
They were
say
having a great
mutual.
time, though.
Yeah, we're going to say mutual congratulations that they all managed to click the buttons and get on the internet at the same time together without help. So let's go ahead and start that real quick.
Hillbilly Blue Balls. The
Good
redneck
start.
retard. So let me show you who we're talking about here. I just want to show the audience that what this is going to be about today. It's going to be about Hillbilly Blue Balls, the redneck retard right here. He had a debate not that long ago against Brian's Logic, and we're going to go through that debate here today. So I just want to let everyone know who we're talking about. Is that okay? We're going to kick it off today. This is going to go pretty much like the last show did, with going through audio, because we want to hear the words that are coming out of their mouths, right? So I'll give you a little teaser of the show. Let me roll that beautiful bean footage. Here we go. Mic discipline, please.
This is what a fair platform looks like.
Okay, what does Atmo mean?
What does Atmo mean?
Yes,
You don't know what Atmo means? Or you?
I do.
Yeah,
I know what it means. Don't play games, Ryan. Just go on with.
Let's go, please. Let's try to kind of.
I'm not. No, this is important.
Wait, Brian.
Important.
It's important, but if you're gonna ask a question of an answer that you know, there's not gonna be nothing that we're gonna learn new. If you don't know what an answer to a question is, then ask it. But if you know the answer, why to play these little gotcha moments? Let's try to really try to progress and move on, please.
Carbon dioxide. What is that?
So this is a fair platform, eh? When Brian asks a question that Brian clearly knows the answer to, and the hillbilly retard doesn't, you come tripping over your clown shoes to save him, and then admonish him for asking a question that he already knew the answer to, but clearly the redneck retard didn't, so you had to come save him. Now, the redneck retard asks, what is carbon dioxide? The answer to which he clearly knew, and you do absolutely nothing.
Okay, guys, we're having enough fun with this. Let's bring Blue back in and let's just chat about a couple things real quick. All right, Blue, you got me back now?
Yeah, I got you.
All right. So what we started off with, and, I think I need to tell you a little something about this stream. A lot of people are saying you need to cut crap out and things like that, and that's going to happen. This is going to be something that I'm going to do a lot of in the future. Right now, for the next month or so, I'm going to do a couple of these where we're actually making the video live with all you guys here, and you have the opportunity to have input through the chat. You can ask questions that you would like answered. There's a lot of things that you can do live with this. Now, in a month, this is going to be a feature that's for the members of this channel. Now, membership is dirt cheap. If you want to do it and want to participate in something like this, that's great. Now, even if you don't join as a membership, on Saturday, this video is going to be made generally on Thursday nights. But on Saturday, I'm going to release the edited and actual production video in full as a premiere. So I will be interacting with people on Saturday with this, but while we're making it, if you guys have a question or anything, you've got to be in this chat. Now, like I said, I'm going to continue doing this for a while. So that's why it's a little rough. You're going to have some switches that are going to be later edited out, some silent periods and things like that. But this is how videos are made. At least this is how I make them. And you'll see the final product on Saturday. It'll be a rebroadcast in the evening on Saturday. So, Blue, why did he ask you what the meaning of the word Atmo was? Oh, David Oliver, thank you all very much. Man, I'm getting super chats all over the place. Isla Moon just joined. Shoot. I've got a couple of super chats here. I'm not used to getting things like that.
You're doing great over there.
Yeah.
Why did he ask that question?
Yeah.
clearly he's clearly trying to get me to say air. I mean, that's all he wanted.
And what's that matter? What matters if the atmosphere is made out of gas?
That's where he was going with it. He's going to take it and say, okay, well, what's air made out of? That's going to be his next question.
Yep.
And after that, okay, well, air is made out of gas and the atmosphere has pressure. So therefore atmospheric pressure equals gas pressure.
Yeah.
That's where he was going.
Yeah. And that's the thing that amazes me. You know, words have meaning in many extent, or for many cases. But the thing is, there's a reason we call something gas pressure, and there's a reason we call something atmospheric pressure. They measure two different things. And we covered that in our interview.
Yeah, if they were the same thing, they wouldn't have two different names now, would they?
No, they wouldn't. That's why we give them two different names. Now, the thing that really confuses these flat earth scholars, and I think that we should call them that. I know that makes the bile gently rise in your lower esophagus, Blue, but we're going to call them flat earth scholars because I really don't like to make fun of the mentally ill. So the reason that they are confused is that both gas pressure and atmospheric pressure have the same unit of measurement, the pounds per square inch. Therefore, you're going to see how they look at some of these stupid things later on in this video. But that's why they're doing it. Now, you're asking about carbon dioxide, and there's two reasons you're asking about that, isn't there?
Well, yeah, there actually was two reasons. First of all, I didn't think Brian understood what carbon dioxide is, and it turns out he didn't.
Surprise, surprise.
Yeah, no big surprise there. But secondly, I wanted to see if he understood what he was getting at when he started talking about plants using carbon dioxide.
Yeah,
and generating and releasing oxygen in the process. That's what I was really interested in seeing. If he had any idea how that process works. And the answer to that, of course, is no, too.
No, I really don't think that he did. But then again, I could predict that he wouldn't know the answer to that. And good God, we've got 286 people already and 118 likes. Shoot, we've been running what? What time is it? We've been running 20 minutes. And do you realize that we've already had more views and likes than Quantum Erasers probably had in a week? That's amazing. And 4 people have joined Team Bob, and I do appreciate it. Now, everybody's honorary Team Bob that subscribes to this channel. But, you know, we've got some C4 join the production team, which is awesome, which means that he and I are going to, by obligation and contractual agreement, we are going to have to do collaboration videos together. So look forward to those in the future. But let's get back to this silliness, because I'm having fun. I don't know about you guys.
Yeah, well, let me say one more thing, too.
Go right ahead.
Let me say one more thing. Brian is, I think, a nice guy, the sort of guy I would probably have a good time sitting down, having a beer with.
He'd be entertaining.
Yeah, he certainly would be. By the same token, after talking, you don't have to talk to Brian very long to realize you're talking to someone that's got, about, the 12-year-old mentality when it comes to science.
Yeah.
And I was trying to take it easy on him. And the other thing but the point I was trying to make is this. When I got him to finally say he didn't know what carbon dioxide was, I dropped it. Now, I could have buried the guy right there on the spot. I could have really made a complete idiot out of him. I chose not to. That's just really not my style. But given what QE has done, I'm afraid Brian is now going to become collateral damage in this.
Do you reminisce with complete strangers?
Yeah, all the time.
Oh, that's the teaser. It's going to be rip roaring, man. I don't know what to say. I mean, what a moron.
Well, if you don't know what to say, call somebody a name.
What do you think about that flare platform? Don't all jump in at once.
We didn't know whether it was rhetorical or not.
Yeah, we were sort of apprehensive about it.
It wasn't rhetorical. You can comment if you'd like.
Yeah, so he's stepping in when someone wants to be having sort of a conversation and know what Atmo means, because just to see if the guy knows what he's talking about, and then the other guy does the thing, but it's just being corrected, and that's a fair platform.
Yeah.
Yeah. Maybe on that side of the argument it is, but here wouldn't fly, I think.
Yeah, well, it's just said. I have a fair platform. It's just a fair platform. That thinks it covers them. That means it has a fair platform. That's like these people that do these debunk videos. Well, just because the video says it's debunked, whatever they're talking about, then these morons think it's debunked. Just because somebody said it's debunked. It doesn't work that way. There's got to be some cowbell to support it, not just words.
I'm sure it's a quote from like some lawyer movie or something, but you never ask a question to which you don't already know the answer. Obviously, he's posing a question, as he called it, to gotcha him, but the gotcha is not like a win for a poignant moment or a laugh. It's a win in terms of a demolition of the heliocentric religion. But they just boil that down to being a gotcha? Like, no, Atmo, I don't even know what the argument is, but I know where it's going. Atmo, being atmosphere, will be described as not being the same as gas. That's what the argument will be. And presumably Brian's then gone, well, what does Atmo mean? So he can have his opponent, who's saying atmosphere is not air, say that Atmo means air, so that it draws a close to that conversation. But rather than that, suddenly that's a gotcha? Well, no, it's just a win for Brian.
Now, don't you just love it the way Okie Dokie is now defining what Blue's argument's going to be?
Yeah.
You know, I don't think Oakley can read his own mind, much less anybody else's, which is pretty evident if you've ever watched him. I don't know. What do you think, Blue?
Oh, he's special, all right, Bob.
Yeah, he's really, really, really special.
Yeah.
But this is their typical thing, and one of the little bear traps, as Blue likes to say, is they like to read you a definition and then hold you to their definition. Now, rule number one when dealing with anybody in the flat earth is I make my own definitions. I will use my definitions, which I can justify. You can play with whatever you want on your definition, but I'm going to use mine. And by the way, here's a little hint for everybody. Independent and dependent variables are not in the definition of the scientific method. Does that kind of surprise anybody? The scientific method is not a checklist. It's an approach to something. And if you want to learn more about the scientific method, watch Friday Science tomorrow. So, anything else you want to add, Blue?
No, you got that covered, I think.
All right, I'm going to head back. Let's get this video going again.
But he doesn't do the same thing with the redneck retard when he says, what is carbon dioxide? It's the same thing. He clearly knows the answer to it, right? So Jose doesn't come tripping all over himself in the same situation, right? Do you find it strange that somebody asks you questions that they have the answers to? This has happened to me most of my life. Did you graduate high school or going to university? Have you heard? Hold on, Arwen. Have you heard of a test? You see, what happens in a test, the professors know the answers to the question, right? But they ask you what it is. Why? So they can evaluate your knowledge of the subject. I know it's shocking. You friggin' bumbling bozo, you. Unbelievable. Yep. That was my teaser. But we're going to get headlong into this, man. Go ahead, Arwen. You didn't have an introduction. Go ahead and move on out. What's up?
Right. Yeah, sorry for bumping in there, but yeah, I do agree with you, but you know, Jose, he is self-admittedly a YouTube host. So he hosts these guys and he's admitted personally, like, yeah, I'm just basically improvising here. I can't manage to get a full oversight. So yeah, he's been honest about it at least. And yeah, whatever these ballers do, they get so psychotic over the place. It's yeah. So he's gonna be subjected to that, and just try to make some kind of sense of it, and try to move on with whatever he's trying to present. But you gotta take into account that he doesn't really have the faculties, admittedly, to deal with all this craziness.
Yeah, you haven't given him the moron allowance.
My word. All right, guys, we're going to get on with this. So remember mic discipline. We're going to go through these sections much like we did the last time. And I'll have breaks in between. I'll let you know for your comments. It would be a good idea if you had something to write your comments down on, because we're going to go through a few sections at a time so you won't forget. All right. Betty, any admin before we begin?
Nope, nothing. You can begin.
All right, here we go.
Nobody's watching you. That's why.
Brian, I wondered if maybe we could go through a few things and see what we agree on. Let's start with this. Do you agree with Newton's first law, the law of inertia, that says?
Go on. Sorry, I got down on you now.
Yeah, it's a body at rest or moving in a straight line at a constant speed is going to remain at rest or moving in that straight line at that constant speed, unless it's acted on by a force. Do you agree with that?
Yeah, more. Do you agree with that? So, no marbles. Do you agree with Newton's first law, the law of inertia? Do you agree with that? Nope. Number one, you yourself consider the Newtonian law of science. Therefore, agree and disagree has nothing to do with this discussion because it's subjective opinion. Actual science is purely objective, empirical. So essentially, it's a non sequitur fallacy right out of the gate. Number two, not only is Newton's first law bunk, all of Newton's laws, that is classical mechanics, are demonstrated poppycock bollocks. This was established nearly 100 free.
Oh, hell no. We're getting Blue back in here. All right, Blue, you knew you were coming in with that one, didn't you?
Yeah.
Yeah, what did Einstein say about Newton? I can't remember.
Oh, I don't know. He had some rather harsh words for Newton. He said something like, neither his theory, Einstein's theory, or any other theory can ever really supersede the great work of Newton. Those are Einstein's own words.
Yeah, so basically Einstein himself said he wasn't superseding Newton. Did both Einstein and Newton agree that mass attracted mass? It was just a different way that it did it?
Yeah, it's just Newton made an observation, Bob. Newton, yeah, that's the way I think about that. Newton made an observation that mass appears to attract mass. And then he said, and I really don't have any damn idea why that is. It cannot just be some innate quality of mass. That doesn't make any sense to me at all. So until somebody can come up with an explanation, I don't want anybody saying I said mass just for no good reason attracts other mass. Einstein came along and said, well, here's why. Mass bends space-time.
I did an analogy the other day when I destroyed QE's gravitation video. Right at the end. You may not have tuned into it, but just in case, I live here in Michigan. We have these thing called white-tailed deer that are they run wild. I mean, what can I tell you? So if I'm driving down a road and I look up and there's a herd of deer grazing on the side of it, what do? Well, generally, I will go into the far lane. One, because they tend to do stupid things when they're startled, and two, because I don't want to startle them. They're eating. And when I get past them, I go back into my own lane. Now, if you ask Newton, the deer caused me to move over. If you ask Einstein, I moved over because the deer were there. All right, you see that slight distinction between the two? The bottom line is, the path that my car took was exactly the same. It didn't matter which way I looked at it. I still did the same thing both ways. So yeah, Newton's laws definitely are still in effect. There is no magic wand that quantum eraser, no matter how badly he wants to deny the existence of gravity because it totally debunks the flat earth, he can't just wave Newton's laws of motion away. They still work. They will always work. I don't know. What do you think?
Oh, they always will. Absolutely. They don't work under certain circumstances, which are well recognized.
Yeah.
That's the reason we have quantum mechanics.
And that's why we have relativity.
Yeah, that's why we have relativity. Exactly.
But
Einstein didn't say gravity was a force. Einstein said it was an object moving through following a geodesic path through as it travels through space-time. That's what Einstein said it was.
Yep.
That's the explanation. Neither one of them nobody's ever yet been able to say, and here's why mass bends space-time. That's still a question.
That'll be for my kids to solve, or my grandkids, or their grandkids. But eventually it will be solved, don't you think?
Well, I hope they hurry up too, because I'm getting old.
Yeah, well, me too. Oh, well. What can I say? What can I say? So, now, let's go ahead and have a look at, let's just make one statement that I talked about with Wolfie the other day, and I don't know if that's already been published or not. But we live in a Newtonian world. We fly airplanes and design bridges and fire artillery shells based on Newtonian physics, do we not?
Yes, we do.
Now, the only time that we actually have to get involved with relativistic corrections is when we're dealing with things moving very fast. Now, one particular case that I can think of where we deal with relativity is with GPS satellites. And that's to stop an error from creeping in. Now, that error will accumulate over time. You know, at first it'll only be a few inches, but after a week, it could be miles. So we have to put these corrections in. Anthony, thank you very much. Thank you very much for that super chat.
After a day, the error would be miles.
Yeah, I mean, it would be pretty useless. We have to use corrections on it. But that satellite that was put in orbit to release that signal was put in with Newtonian physics. Now, Dr. Phil Bell, who actually put satellites into space, has confirmed that repeatedly. So I'm going to go ahead and get back to the video here. You got anything else you want to add there, Chief?
No, I'm good.
All right. Well, back we go to the silliness.
Freaking years ago. From Richard Feynman. The discovery of quantum mechanics first, and then in the behavior of light, and then in the behavior of matter, finally culminating in 1926 with a full equation of quantum mechanics, which told us that the laws of motion of Newton were not right. Let me say that again. The laws of motion of Newton were not right. From Professor Shankar, Chair, Professor.
Okay, quantum eraser, before we go on, I'm just going to put a personal note out here. First, we don't deal with quantum mechanics when we're building bridges and flying airplanes and shooting bullets. All right. Second of all, yes, there is a slight difference. Now, here's your challenge, Sonny. I'll calculate things based on Newtonian physics. You do the math to calculate them on quantum mechanics. And then you show me where an error is. Because, sir, your own citations, the ones that you are going to be quoting later in this video, and I nailed you on the other day, disagree with you. They say that for objects that are not massive and are not moving at close to the speed of light, Newtonian physics can be used in all circumstances without fear of error. Now, the only reason that quantum mechanics is involved is you're dealing with particles. And while I'm at it, since you understand quantum physics so well, I'm going to tell you a quantum physics dad joke. See if you get it. So, a priest, a rabbi, and a particle walked into a bar. Or they didn't. Thank you, folks. I'll be here all week. Back to the video.
That is the end of Newtonian physics? From your alma mater wiki, Newton's classical mechanics. That's everything. That's the universal law of gravitation and all of his laws of motion, by the way. Newton's classical mechanics were superseded in the early 20th century when Albert Einstein developed the special and general theory of relativity. Now, I know you have a problem with the word superseded and the word and is. Let's go through it step by step. From Cambridge Dictionary, supersede, to replace something, especially something older or more old-fashioned. From Merriam-Webster, to cause to be set aside. To force, now the irony, to force out of use as inferior. Number 2, to take the place of or position of. Number 3, to displace in favor of another. You get it? Superseded. Oh, and by the way, from Caltech, Professor Jacob Bekenstein. Also, Einstein replaced the Newtonian law of motion by the statement that free test particles move along geodesics, the shortest curves in space-time geometry.
Yeah, I think we're going to go ahead and just continue with this. I was going to actually show you Einstein's letter where he says that he doesn't supersede it. So we'll keep going.
And just like the last iteration with Professor Bell, folks, I'm going to play these twice. The short ones, I'm going to play them twice in succession. So if there's any misunderstanding about what he said first, then it'll clarify itself in the second one. The little bit longer ones, I'll let you know that I won't play again. Okay, no marbles. F equals MA. You have any problem with that? Yeah. Classical mechanics, Newtonian mechanics is demonstrated bunk. See directly above. We just went over it.
Okay, matter is pretty much a synonym for mass.
Sure about that? Matter, no marbles. Matter is pretty much a synonym for mass. Yes, and Pocahontas was actually Elmer Fudd and Drag. From sciencelearn.org, the atoms of molecules and gases are much more spread out than in solids or liquids. They vibrate and move freely at high speeds. Again, moving freely, not just one vector. This one just comes out and says it straight up. From victoria.gov, in gases, the particles move rapidly in all directions. All vectors. You have only one vector toward the earth, toward the ground bullshit. You're finished. It's over right there. We'll pile on. Violation of the laws or the entropy laws or second law of thermodynamics. The limiting of vectors by delusional double-speaking Dunning-Kruger numpty dipshits, such as yourself, reduces the number of accessible microstates. When the definition of entropy in molecular thermodynamics is the change in a system or surroundings or their total, from which there are fewer accessible microstates to one for which there is an increased number of accessible microstates. See, reduces, you're holding that it reduces. This says increased.
All right, guys, we're going to have a little bit of fun with that. So let me bring Blue back in real quick because I think this is something he wants to do. Blue, you back there?
Yeah, I'm here. I wasn't hearing the audio.
I got you. All right, I want to show you guys something real quick. Now, what he said very clearly was that the law of entropy, which he's calling a law of entropy, which is kind of like Newton's universal law of meters per second squared. So here we go. So let's look at a little bit of a equation here. So let's take 6 carbon dioxide molecules and make that go to, I think that's right. So let's look at something here real quick. Now, what he's got very clearly is we have 6 molecules here and 6 molecules here. That equals 12 quantum eraser. Go to 1 molecule plus 3 molecules, right? I made a mistake.
6.
Yeah, it's 6. Sorry about that, guys. My bad. Let's try that again. So what we have is we have 12 molecules going to 7 molecules, including one that has 24 atoms in it. So this is an increase in complexity, isn't it? We'll look at this again a little bit later. So there's your law of entropy. I wonder how that happens there, Sonny. Any idea? So, any thoughts, Blue? Any thoughts, Blue, before we go back?
Yeah, I wanted you to give it to QE just as CO2 plus H2O going to sugar plus O2 and ask him to balance the damn equation. I bet he couldn't do it.
Oh, I don't. I know he couldn't. That's why I put it in. But then again, I screwed it up the first time too. That's why I had to look at it. But the difference is I know what I'm doing. So when I looked at it, I realized what I did and I fixed it.
Yep.
That's the difference between me and QE. QE doesn't learn anything. I learn things.
It's a contradiction. And by the way, Sir Arthur Eddington again, if your theory is found to be against the second law of thermodynamics, which yours is, I can give you no hope. There is nothing for your theory but to collapse in the deepest humiliation.
So's that one, Sonny. How's that work out for you?
Pummeled again. You'd not only fail 5th grade general science, you'd struggle in a 60-level basic reasoning course. Check this out.
We measure the rate that things fall. Is that how we determine the gravitational constant?
No, that's not how the gravitational constant was arrived at. That's not how you can derive or measure the gravitational constant. You can't derive it in the first place. You've got to. It had to be measured. Still has to be measured. How
is it measured, though?
But it's a constant of proportionality. How is it measured? That's what Cavendish did.
That's what Cavendish did. So Cavendish came up with the gravitational constant? Really? Well, that sounded really good. Wrong. Cavendish didn't calculate a numerical value for big G or M. From the Michelle Cavendish experiment, Laurent Hodges, Department of Physics and Astronomy, Iowa State University. Let's read some of this before we get to the punchline. Did he give a numerical value for G or for M? How accurate was his value? And in what units did he express his result? Not finding an answer to these questions, alarm bells, in any of the textbooks that I checked, I decided to read Cavendish's original paper in the Philosophical Transactions for 1798, a copy of which resides in our library. Yeah, one resides in my library too there, Laurent. Cavendish's paper did not disappoint me in this respect. There were 3 major surprises awaiting me. Listen up. First, Cavendish did not determine either G or M. He determined the average density of the Earth. I got another question here. If density equals mass over volume, and he didn't calculate mass, how can you find density? That's a rhetorical question. He not only didn't know the mass, whatever that is, because no one can define it, he didn't have the volume either.
Yeah, I think we got a little special treat for QE on this one.
Yeah, you know you're coming in on that. Okay, so why don't you just go ahead and give me a quick idea of what you want to talk about here?
Well, is this a good time to play that video, or should we? I'll tell you what. Let's just talk about it for a second, and
Okay.
then maybe we'll play the video.
Okie dokie.
Cavendish, in fact, determined the density of the Earth. That's not an untrue statement. He found it to be, I forget what the number is now, something like 5.48. The Earth has a specific gravity of about 5.48. In other words, 5.48 times as dense as water. That's what Cavendish really did. But Cavendish very well knew what the diameter of the Earth was. He states it in the paper that QE should have read. He states the diameter of it. Well, if he claims he read the paper, he had to read that. So one of 2 things has happened. Either QE is lying about reading the paper, or what would be the other alternative? Everything you need, the only other thing you need, aside from what Cavendish the measurements Cavendish made. The only other thing you would need is to know little g. If you knew the acceleration of gravity here on the Earth, you can easily come up with big G. It was all right there. It just took a while before anybody put it all together and stated it in one long, coherent statement.
So basically, the bottom line is QE either did not read the paper and claimed to have read the paper because that's his usual MO. What he does is he cherry picks something out of a 60-page paper, and he'll ignore everything else in the paper, including the remainder of the same paragraph that he got his stuff out of. Or he does know it, and he's lying about it, which is why he's basically intellectually dishonest. We've seen that many, many, many times in the flat earth. The most famous one is the Tesla quote about scientists nowadays get lost in equations. We've all heard that. If you go back to the actual magazine page that comes from, that's on the bottom of page 42. On the top of page 42, Tesla is talking about using the rotational speed of the Earth to help put a rocket into orbit around the spherical Earth with the above the atmosphere. So they conveniently neglect that. That was quite a bombshell I put out a while. So, Blue, you want to show them that video real quick?
Yeah, you got it up?
Yeah, I always have it up, Blue. I'm Bob.
I knew you were going to say that.
That was 12-year-old Bob coming out. Sorry about that. Let's go see if we can pull it up.
Okay.
Is that it? Because I pulled that up just a little while ago. No, I don't think I do have it. So let's go ahead and get that. Give me a second. We'll get that taken care of. I've got it here in the side chat, so give me just a second. I think I should be able to pull it right here. This is a little video that BlueMarbleScience made for me. And I think you guys will enjoy it. I'm going to let you guys watch it for a second. I'm going to step out.
Quantum Roaster says he has a copy of Cavendish in his library. Really, Kiwi? Why didn't you read the damn thing? Let's take a look at my copy of Cavendish. Let's read what he says over here on the left side. Since you said he doesn't know what the volume of the Earth is, the mean diameter of the Earth is 41,800,000 feet. 41,800,000 feet. That is 3,958.3 miles in radius. That number sound familiar to you, QE? Let's see what else he knew. By a mean of the experiments made with the wire first used, the density of the Earth comes out 5.48 times greater than that of water. And by a mean of those made with the latter wire, it comes out the same. So Cavendish measured a specific gravity, don't you hate it? A specific gravity for the Earth of 5.48. What could we do with those two numbers? Now, warning, buddy, there's some 5th grade math coming. Be careful. The volume of a sphere is 4/3 pi r cubed. For a sphere with a diameter of 41,800,000 feet, the volume is 3.824 times 10 to the 22nd cubic feet. The density of water is 62.3 pounds per cubic foot. The density of the Earth, therefore, is 62.3 pounds per cubic foot times 5.48, and that yields 341.04 pounds per cubic foot. Notice the little m behind the LB? That stands for pounds mass. We use pounds as both mass and force. If it had been a force, I would have written LBF. I don't want you getting excited thinking I made a mistake or something. All right, back to this. Mass of the Earth is therefore 341.04 pounds per cubic foot times 3.824 times 10 to the 22nd cubic feet, or a mass of 1.303 times 10 to the 25th pounds. That's pounds mass. We can convert that to kilograms by dividing by 2.205, and you end up with 5.9098 times 10 to the 24th kilograms. Wow, that's within 1% of the number we use today. But we could find out something else too if we had wanted to, and so could Cavendish. Careful now, QE, we've moved up to 7th grade math this time. If you look over here on the left side, this is the way Newton originally wrote the equation. F is proportional to m1, m2 divided by r squared. You've made a big deal out of this, and now we're just going to take you apart. If you knew anything at all about math, QE, you would know that proportional to means there is a constant of proportionality that you can add if you wish. And you can make that equation say equals. And we can do that by adding the constant of proportionality, which for us is what we call big G. That's what we got from Newton ultimately. We got something else from Newton. He also gave us force is equal to mass times acceleration. Now imagine, if you will, I set those two equations equal to each other. I'll end up with acceleration equals G times m2 divided by r squared. M2 being the large mass, M2 being the Earth. Now acceleration, A, is equal to what we call little g, and it is a measurable quantity of 9.81 meters per second squared. That hasn't changed since 1798. We can solve the equation in the upper right corner for big G and find that that is equal to little g r squared divided by m2. We now have everything we need. And Cavendish would have had everything he needed. He just didn't state it this way. When we run through the numbers, we get a value for G, which Cavendish could easily have stated as well, he just didn't, of 6.7456 times 10 to the minus 11th. That, again, is about 1% off from the accepted value today. I'll say it again, buddy. Why didn't you bother reading this? I know. You're an idiot.
And I think that pretty well sums that up. I don't think we have anything else that we need to add to that. Let's go see if Blue had any comments. You still hearing me, Blue?
Yeah, I'm hearing you. That's all I had.
All right. Well, let's just go on to where we're going. Let's go see where the next section takes us. This is getting fun.
Yeah.
So how can you find it? Unbelievable. Unbelievable, man. So, just bottom line, Cavendish didn't calculate anything to do with Big G. He's just talking out of his ass and making shit up. That's because that's who he is, and that's what he does.
Cavendish measured, actually what Cavendish was doing was not coming up with a gravitational constant. Cavendish came up with the mass of the weight of the Earth. He was looking to determine what the mass, the weight of the Earth is.
He was, huh?
Yeah.
No marbles. Cavendish came up with the mass, the weight of the Earth. Wrong! Well, which one? So does mass equal matter equal weight? Still hillbilly blue balls.
Okay, let's just clear that up real quick. Cavendish was actually looking for the density of the Earth. And he did it by means of specific gravity. Now, knowing the value of G, which you can get from Cavendish's equations, you can very easily find the mass of the Earth. I calculated it myself. So it really isn't all that difficult to do. Now, what QE is trying to do is he's trying to make a distinction without a difference here. Now, if you know the density and the volume of the Earth, you know its mass. That's middle school science, which apparently is about as far as Quantum Eraser got in science, because I remember reading something from him that he was bragging that he had already learned everything he needed to know about science and felt a little bored in junior high because he had already been over the material. I think that just says volumes. But let's go ahead and continue here.
How about neither? From what we just read from Lauren Hodges. First, Cavendish did not determine either G or M. He determined the average density of the Earth. We just went over this, right? You're just making this up. But you're saying it with conviction like you know. You parroted this nonsense from another baller who knows where he got it from. You didn't do your due diligence or scrutiny. You've been saying this for the past year. All this nonsense. You're exposed. You can't recover from this. This is hilarious. It's going to get better.
Yeah, as a byproduct of that, once you have that, you can then go backwards and figure out what the gravitational constant had to be. It wasn't a hard thing to do. He did it really by ratios. You consider three separate bodies. You consider in the Cavendish experiment, he had some large weights. He had some little small weights on his balance, on his torsion balance. And then the big weight is the weight of the Earth. Yeah.
The big weight is the weight of the Earth.
Yeah, as a byproduct of that, once you have that, you can then go backwards and figure out what the gravitational constant had to be. It wasn't a hard thing to do. He did it really by ratios. You consider three separate bodies. You consider in the Cavendish experiment, he had some large weights. He had some little small weights on his balance, on his torsion balance. And then the big weight is the weight of the Earth. Okay.
Blue, do you have anything else to add on that?
I think the only other thing I will say is keep in mind I was trying to explain something to a 12-year-old.
Exactly.
And when you do that, you don't make fun of the 12-year-old. You just try to say words that might ring a bell with them. That's all.
Now, QE is not a 12-year-old, is he?
No.
So I don't have a problem making fun of QE, who is clearly over his head with this. Do you see, folks, what he's trying to do? He's trying to split the definition of words. Now, if you know the density of a sphere, do you not know the weight of the sphere? Of course you do.
Yeah.
Now, the fact that you didn't measure the weight directly, you measured the density, doesn't change the fact that you have the weight of the sphere. That's ridiculous. And by the way, I do want to put something out. I put out several offers to QE to come here and participate in this and defend himself. Anybody see him? I didn't think so. So QE, or excuse me, why do I keep calling you QE, Blue? What on earth would cause me to confuse you with him?
I don't know, and I'm really disturbed by that.
Well, I'm sorry to have disturbed you. Let's get back to this thing or else we're not going to get done. Now, let's put a little poll out in the audience. This thing that QE put out is over an hour and a half long. Or excuse me, it's over 3 hours long. And we still have a long ways to go on it. How long do you want to keep this up? I mean, how long do we need to make the rubble bounce here? Have we already shown that QE is completely hopeless? Or shall we just continue to poke him? So I'm going to let some things get in chat. I think I accidentally hit this thing. I don't think it's necessary to go over all this. Gravity is not a force thing. I've already destroyed that.
Yeah, absolutely.
I think we can probably go to right here and get that
There are
going.
fewer accessible microstates, the one in which there is an increased number of accessible microstates. You have it reducing. This is increasing. This is from the entropysite.oxy.edu. This is a second law of thermodynamics violation you just postulated there, redneck. And a force, but as a manifestation of the curvature of space-time.
In the saying about these citations and stuff, people in the chat were saying cherry picking.
We're going to get to that. Thanks.
Started more of these citations and stuff, just still cherry picking.
Yeah, we're going to go over it here in a little bit. You just made horses' asses out of yourselves, right? I can't wait. Yeah, thanks, Betty.
Does Einsteinian work for more than one mass?
Yeah, say that one more time, Nathan.
Can you calculate more than one mass with Einsteinian's formulas?
No, we're going to get to that here in a little bit. And what's mass?
Well, that's something I was going to bring chocolate in, because earlier you were talking about his conflation between what chocolate describes in Will Smith's words as old and busted versus the also debunked new hotness that is Einsteinian gravity. So he's conflating the two, despite the fact that I'll paraphrase, the laws of Newton were not right.
Yeah, the laws of motion were not right. Yeah, Richard Feynman. Yeah, he just didn't say it. Right? I can support with serious cowbell all those citations. Right? You got to understand, though, just for the audience, citation support is wonderful. But then the second layer is you better support what's in those citations.
No, QE. The first law of citations is you don't cherry pick out one sentence in it without reading the actual citation. That's how I destroyed you on your gravity paper. And I would encourage everybody to have a look at that gravity video that I did debunking quantum eraser. He literally cherry-picked words out of paragraphs while missing the entire meaning of the paragraph. It was kind of funny. But let's go ahead and continue with this.
Because anyone can say anything, even Richard Feynman. On its face, it's a baseless assertion fallacy, unless you got cowbell supporting those statements. And you know I can support each and every one of them. Right? But for brevity, I've already done it in the past. For brevity, we'll continue. But he just told you right up front, pretty positively, that the laws of motion were not right, because they're not. Period. End of story.
That's the quote. The laws of motion of Newton were not right, Richard Feynman.
Yep.
But basically, they were right within a certain frame of reference.
Wrong.
And then when you move beyond that, which is the
wrong,
the more real
smartest thing said on the entire panel.
Incorrect.
Then, of course, you bump into the obstacles that disprove it.
Incorrect.
It's like a very basic mechanism.
Incorrect. They're wrong. They can't be right and wrong. They're either right or wrong.
You know, folks, let's just take a moment here and think about this. Not only is QE wrong, Arwin is correcting him. Arwin. Let's just contemplate that for a second. Back to the video.
They're wrong.
Okay.
Chocolate.
I just want to get it down according to all the citations you just read. So gravity is not a force?
Those are cherry picks.
Oh, those are cherry picks. Because I find it kind of to be some type of a mass delusion that these guys are going through. Like, this is their side saying that their nonsense is not a force. Yet they come to us and tell us it is. It's so weird. I just don't get that shit, man.
Because that's what your citations say.
They're aligning with Newton, and I don't know how many times we got to tell you that all of Newton's laws are bunk. I just showed you, right? We know that Einstein isn't a force, for crying out loud. Come on, people. Anything else, Chocolate?
No. Sorry I got here late.
No, that's okay.
Good to be here.
That's okay. I'm used to it. Kaiser Soze, Robert Bassano, sir.
In the words of David Russell, We live in a Newtonian world of Einsteinian physics ruled by Frankenstein logic. End quote. End quote. That's all I have to say.
Yeah, it's a joke out there, folks, man. I'm telling you. And by the
I like
way,
that quote.
He's
Hillbilly-
British, by the way, David Russell. He's British. It's a Brit who said that. Ironic.
By the way, Hillbilly, if you're not keeping track, everything you said thus far has been wrong. That's got to be a record. I mean, do you think you're going to get away with this? I mean, maybe with the retards over on Jose Retard's channel, yeah, because they're dumber than you are. You haven't got anything right thus far. Wait till you see the rest of this. You can't recover. Bozo, the photosynthetic hillbilly blue balls, redneck retard. We're going to have to rename you after this.
Why is it then that Albert Einstein, over 100 years ago, stopped calling gravity a force and he called it an effect due to the curvature of space-time by matter?
Well, it is. That's exactly what it is.
That's exactly what it is. I thought everyone out in chat was saying that it was a force. Huh? So the first comment I brought forward for continuity.
I think I cut you out all the audio, didn't I, Blue? Well, this is the famous, Einstein stopped calling gravity a force 105 years ago or whatever it was. Okay, yeah. And QE put up a bunch of citations that said gravity is not a force. Yet every single one of those citations, his own citations, which he would have seen had he actually read them, says, but it manifests itself as a force, and you can use it, you can treat it as a force without fear of error for most situations. So what exactly point are they trying to make here?
You got me. I couldn't hear the audio, but they harp on this all the time. They need to get rid of Newtonian physics.
Yeah, they do. Why do they need to get rid of Newtonian physics?
Well, if they can get rid of gravity as an acceleration, I'll call it an acceleration. Okay, if they can get rid of gravity as an easily understood force / acceleration, then they can they can take it the next step and say, well, atmospheric pressure can't be caused by gravity because gravity doesn't exist.
Yep. Well, it's deeper than that. You see, the reason that the flat Earth has got to deny gravity to maintain consistency with their narrative is if gravity exists, the flat Earth cannot.
Yeah,
Any large object, hundreds of miles in diameter, certainly something the size of the flat Earth, if gravity actually existed, would immediately collapse into a sphere, because that's what gravity makes large objects do. That's why every single large object that we see in the universe is a sphere. It's got to be a critical size. I think it's something like 300 miles. But any significant object in the universe collapses into a sphere because of gravity. And if you allow gravity to exist in the flat Earth cannot exist. Since it's so inconsistent with their narrative, they have to deny it. They have no choice.
Yeah, it's the linchpin for them.
Yeah.
They absolutely cannot afford to have gravity. If you have gravity, you don't need a dome.
Nope.
You have gravity, you can have that magic space vacuum that they accuse us of talking about all the time.
Yep.
All of the things you said, plus what you just got through discussing. Yeah. Small objects that we see in space are very irregular shaped usually. But as they become larger, the larger they become, the more spherical they become. Every one of them. Even when they're made out of gas, they become spherical.
Yep.
How does that happen?
So I'll tell you what, flat Earth, I'm going to go ahead and absolutely destroy your entire world right now. You're done. Goodbye. But let's listen to this silliness just for nothing more than our personal amusement, because it's amusing to watch people flounder.
Gravity is
Oh,
it not?
that
He
it
said
is.
yes. So this is following up. Question. Why is it then that Albert Einstein over 100 years ago stopped calling gravity a force? He stopped calling gravity a force. You understand what stop means? Probably not. And he called it, in effect, due to the curvature of space-time by matter. No marbles. Well, it is. That's exactly what it is. So Hillbilly Blue Balls knows it's not a force. Wrong. Number one, law of non-contradiction violation via the law of identity violation. Something can't be a force and a force at the same time. They're two mutually exclusive truths that you're holding at the same time. That's a law of non-contradiction violation.
Did he just try to use a grammar law to prove the flat Earth? I mean, seriously?
Via law of identity violation. Just that simple. This is second grade. Incoherent second graders would be rolling their eyes. My word.
It is the curvature of space-time. But Einstein did nothing more than add to Newton's theories.
He did he? No marbles. It is the curvature of space-time, but Einstein did nothing more than add to Newton's theories. Wrong times 5.
Well, not according to Einstein. That's exactly what he said.
Add a non-force description to a force description without invoking a slap in the face contradiction like we just went about over above. Number 2, non sequitur again. Sir Isaac Newton never, ever even postulated, much less validated, a single scientific theory in his life.
Oh, dear God. You know, QE, let me just kind of clue you in on something. I would like you to present one peer-reviewed paper in a scientific journal that says this experiment, this finding, this theory is wrong because it invokes a logical fallacy. I don't give a rat's behind about your logical fallacies. First, you don't know how to use them properly. Second of all, this isn't a formal logical argument, so they don't even apply. And third, having a logical fallacy Tourette's and shouting them off is a disruption tactic that you and Nathan like to use. Here's the clue. You still have to actually present evidence to disprove the conclusion. I don't care if you scream logical fallacy. You still have to disprove the conclusion. Prove to me that object is not being accelerated by an outside force. I'll wait.
Number 3, actual scientific theories never, ever add anything to actual natural laws. Because if they did, then it wouldn't be a natural law anymore. Duh! Number 4, Albert Einstein never proposed an actual scientific theory in his life either. Number 5, as identified previously, all Newton's laws were superseded by Einstein. We wanted to go over it again.
Oh, dear God, no, I really don't want to go over it again. But, Blue, we need to go over that again, don't we? Any thoughts?
Yep, QE is certainly an idiot.
It's kind of like having a
that.
3-year-old do your taxes, isn't it?
Yeah.
But it's fun to watch. But, you know, I got to thinking about it. It's kind of like watching a 3-year-old play with a loaded shotgun. You can't take your eyes off of it, but it really is not a good situation. It just isn't.
That's
and,
right.
You know, what is it with quantum eraser and trying to play a definition game with a dictionary? Is science done by the dictionary?
It never occurred to me that I could study physics just by reading a dictionary.
You know, I'll tell you something that I've said a lot of times, and that is that if you need a dictionary to tell you what something means, you don't know what it means.
That would be very true.
You know, for example, he likes to talk about scientific method, and I don't think he even knows the difference between an outline of an experiment and scientific method. Tune in tomorrow. Little plug for my show tomorrow. But in any event, that's been a lot of fun. Do you have anything else you want to add on this one? Or do you want to go back to it?
Oh, that's good Lord. No, I think that's enough of that foolishness. Huey knows what he's doing.
From your alma mater wiki, Newton's classical mechanics, that includes everything, laws of motion, universal law of gravitation, were superseded in the early 20th century when Albert Einstein developed the special and general theory of relativity. Right? These aren't theories, by the way, not actual scientific theories. There are no hypotheses that have been validated. There's no experiments. That's why I said that. Do we need to go over what supersede means again? I'm not going to. I'm not going to insult some of the people out there, their intelligence out there. I'm not going to do it again. Crying out loud.
You take Einstein's equations, his field equations, at the weak field limits, you get exactly the same thing that Newton had.
You mean the weak gravitational field? You have yet to validate that. No marbles. If you take Einstein's equation, his field equations at the weak field limit, you get exactly the same thing that Newton had. I love your attention to excruciating detail here, redneck. Yes, and Liberace's grandmother was a Saudi prince and...
Well, that's actually enough of the abusive crap from QE. We'll bring Blue back in here. Now, Blue, you probably, being an engineer and an electrical engineer, probably did a lot more relativity than I did and worked with Einstein a lot more than I did. But the bottom line is, and every citation that QE put up agrees with me on this and disagrees with Quantum Eraser. And that is, as long as we're not massive like a black hole or moving right close to the speed of light, Einstein's equations reduce to Newtonian equations. You can use them, you can use Newton without fear of error. And that's what QE's citations say specifically. You can use them without fear of error because the difference between the two are so small. Now, QE, I'm going to put the challenge out again. I'll use Newton. You use Einstein. You do the math and show your work and show me how there's a difference. I'll wait. Do you have anything else you want to add to that, Blue?
Well, what you said is perfect. And I didn't say anything wrong either. At the weak field limits, you will get exactly the same result from either Einstein or Newton. That's just the way it goes. Yep. In fact, any theory of gravitation, regardless of whether we're talking about Einstein or something in the future, at the bottom end of it, it has got to reproduce Newton's laws. It has to. If it doesn't, it's wrong.
Yep. That's basically what it is. If it doesn't match Newton for building bridges, it's wrong because Newton defines what we build bridges with.
Exactly.